So the question that we'll be doing today is determine the exact value of sine 45 degrees multiplied by cos 180 degrees minus sine 60 degrees times tan 210 degrees. Now, first thing that we have to do is to convert the degrees into radians. So this would equal sine pi over 4 cos pi minus sine pi over 3 and tan 7 pi over 6. And just to show you how I got those values is I'll do some side work. So to convert degrees into radians, what we have to remember is 360 degrees equals 2 pi. And 180 degrees equals pi. And we also have to remember that the rule is that you take the degrees and you multiply it by pi over 180. So for the 45 degrees, it would equal pi over 4, because when you take the 45 and you multiply it by pi over 180, you'd get pi over 4. For the 180, we already know that that equals pi. For the 60 degrees, again, you do the degrees times pi over 180, and you get pi over 3. And for the 210 degrees, do the same thing. Put it in your calculator. Degrees times pi over 180 equals 7 pi over 6. So that's how we got those values. And now we want to get these just into values, so we just want to kind of drop the sines, the cos, and the tan. So what we would get after that is 1 over root 2 for the sine, and that would be multiplied by -1 minus root 3 over 2, and then for the tan, we would get root 3 over 3. Now how I got those values is for the pi over 4, we know that's in our special triangles. So we look at our special triangles here, and we also know that sine is opposite over hypotenuse. So we look at a pi over 4, you go to the opposite, which is 1, and the hypotenuse, which is the root 2. And then we also have to look at our CAS rule, and we know that pi over 4 is in the first quadrant, so that means it's positive anyway. So it's just 1 over root 2. And for the cos pi, now we know pi is in our special unit circle. So, and then we also have to remember that cos is equal to x. So we look for pi, which is here, and we look at the x value, which is -1. And that's how we got that value. Now for the sine pi over 3, again, we look at our special triangles, and we have to remember that the sine of theta equals opposite over hypotenuse. So we go to the pi over 3, and the hypotenuse is 2, and the opposite is root 3, so it's root 3 over 2. And again, we have to look at the CAS rule, and we know that pi over 3 is in the first quadrant, so they're all positive anyway, so sine would be positive, so that just means that it's pi root 3 over 2. And then for tan, 7 pi over 6, what we do is just to show some side work here. So when we have the 7 pi over 6, right now we're just looking at this value. We're just looking at pi over 6. So we'd look at our triangles, because pi over 6 is in the triangles. And tan of theta is opposite over adjacent. So that would equal 1 over root 3. So the tan pi over 6 equals 1 over root 3. Now again, we have to look at our cast rule. Now 7 pi over 6 is actually in the tan quadrant. So that means tan will stay positive, which means it just equals 1 over root 3. Now how I got the root 3 over 3 is I just rationalized it. You can rationalize it all at the end, but I prefer to do it as I go. So I just rationalize that right now. And then after that, pretty simple, we just start multiplying them. So this would equal root 2 over 2 if you take the 1 over root 2 times negative 1. This would be negative. And then you do minus. This ends up equaling 1 over 2. And then again, you just subtract these. So this equals negative 1 minus root 2 over 2. So that's our value. You can also write this as, just if you don't like the negative 1 in front, you can write it as negative root 2 minus 1 all over 2. Either way is fine. They're both correct answer. So therefore, the exact value is negative 1 minus root 2 over 2. So that's how, from sine 45 degrees and having all the degrees, we would finally get the exact value of negative 1 minus the square root of 2 over